Good day to you all. As people are joining from different parts of the geographies, I wish to say hi, hello, and welcome to this Python workshop. We are starting this workshop with an apology note. Dr. JK from Saudi Arabia, the chair of this session, is unable to join due to certain unavoidable reasons. Be whatever it is, I'm Dr. Krishnan Umachandran. I'm going to be the chair of this session. First of all, without wasting time, I would call upon Sangeetha, Assistant Professor Sangeetha. I'll introduce you, and you can take the chair, please. I mean, the position for presenting. Professor is for the last 12 years, she's been teaching, and now she is Assistant Professor in Department of Computer Science, St. Hindu College, Nagarkoil in Tamil Nadu. She has been a participant in many of the international conferences, and she has presented her articles and research work. She has published in many international magazines, and she has done a lot of methodical reviews. She has done training and learning in Python and in various other emerging technology tools. Without wasting time, she's a certified Python expert and data science. She has very good exposure on Python, machine learning, and blockchain. With this short introduction, I wish to hand over the floor to Professor Sangeetha. Sangeetha, please take it up, please.
Yes, sir. Thank you for giving me such a wonderful opportunity in this learning platform. First of all, I would like to share this screen. Is it visible, sir?
Yeah, it is visible. Go ahead, please.
So my topic is web app development with Django. First, let's see a small introduction about Django. Django is a high-level Python web framework that encourages rapid development of secure and maintainable websites. It has been built by experienced developers, so we can focus on writing our app without needing to reinvent the wheel. It's free and open source. It has a it takes the security seriously and helps developers to avoid many common security mistakes while developing the web application. It is exceedingly scalable. Some of the busiest sites on the web leverages Django's ability to quickly and flexible scale. The high profile websites like Google, Pinterest, Spotify, Instagram, all these uses the Django's web framework. Why Django framework to be used? Because Python source distribution has long maintained the philosophy batteries included. Batteries included in the sense it is having a rich and versatile standard library which is immediately available without making the user download separate packages. It means that something is self-sufficient, comes out of the box ready to use with everything that is needed. It is versatile that for even a content management system like Wikipedia and all through to social media networks, we can use Django web framework efficiently. It can work with any client-side framework and can deliver content in any format, including HTML, JSON, XML. Django enables protection against many vulnerabilities by providing a framework that has been engineered to do the things right, to protect the website automatically. For example, it provides a secure way to manage user accounts and passwords. In normal, if we are creating a website, we have to, the passwords are directly stored in the databases. But here, Django provides, instead of storing directly the passwords, Django provides password hash. So Django can check if an entered password is correct by running it through a hash function and comparing the output to the stored hash value. In this case, if someone has compromised the password, means only when the attacker is, for example, due to the one-way nature of the function, even if the stored hash value is compromised, it is hard for an attacker to work out the original password. Django uses component-based shared nothing architecture. It means that Django enables a protection against it is a scalable. It is a scalable that each part of the architecture is independent of the others. That is, it is loosely coupled. The each modules are loosely coupled. So anytime we can reuse the modules. It makes the use of the don't repeat yourself. That is mentioned as dry. There is no unnecessary duplication. In that way, we can reduce the amount of code. It is portable, means applications can run on Windows, Linux, and Mac like this. In different platforms, we can run this Django framework. How popular is Django? Yes, Django is a popular framework. How we can calculate the popularity means it is based on the number of high profile sites that use Django, the number of people contributing to the code base, and the number of people providing both free and paid for support. Here I have listed some popular high profile sites that use Django, which includes Discuss, Instagram, National Geographic, Pinterest, etc. This is the Django architecture. We call it as MVT, Model View Template Architecture. MVT is a software design pattern for developing web application. Here model and the model is going to act as the interface of our data. That is, we are going to store all the data in the databases. So here the model represents the databases. View in the sense, the view is the user interface, what we see in our browser when we render a website. That is what the content inside the view. It is represented by HTML, CSS, Java, and Jinja files. Next, the template. The template consists of static parts of the desired HTML output. It is mainly used for the styling purpose. Why we need to set up a virtual environment? In Django, we will be using virtual environments. It is recommended to create and execute a Django application in a separate environment. For example, if one of the project might require a different version of an external library, that another one. If we have only one place to install packages, then we can't work with two different versions of the same library. This is one of the most common reasons for recommendation to use Python virtual environment. So here, to create a virtual environment, the command venv is used, and then we have to give the virtual environment name. In Django, it uses the concept of projects and apps. A single Django project contains one or more apps. One or more apps means I'll show. For example, if we consider a blog as a project, means it contains different apps like comments, different modules like comments, post, login, logout, etc. All these we consider as modules, but here we call it as apps. Each project contains many apps. So these apps are loosely coupled, and whenever we are creating another web application, means we can reuse these apps in that websites. A real-world Django e-commerce site might have one app for user authentication, another app for payment, and a third app to power item listing details. Each focuses on an isolated pieces of functionality. That's three distinct apps that all live within one top-level project. That is the concept that we are here having that. Blog as a project and all these as apps. And these apps are reusable and it is loosely coupled. So whenever we are using other whenever we are developing other projects, we can reuse these apps. Debugging and organizations is also easy, and it is somewhat error free. And the main thing here is, whenever we create each and every single app, there is some we have to navigate to the settings.py file. In there, we can see a folder named installed apps. In that installed apps, we have to list whatever files whatever apps we create, we have to list of that. So in the MVT, just first we are seeing the view. Views is where we handle the request response logic for our app. When the here first we start with the user. When the user sends a request through an URL, the view here contains the content to be displayed will be in the view part. A view part. After that, taking the response, the template will take that content and style it and display it as the response to the user. Django models represents where we define our database models, which Django automatically translates into database tables. We all know that when we design a database using DDL and DML for creating, deleting, updating, and all other stuff, it is somewhat complicated, but Django automatically converts these into tables, and it is easy for each compared to SQL. Next, we are going to see about the Django template. It is also one of the part of the MVT structure. Actually, I already told that it is used for the styling purpose. We have to create a folder called the templates, and we should put all the HTML files inside the templates folder. And after that, we have to navigate to the settings.py file, and there we have to connect where the template file can be found. So there are 2 to 3 methods to do this. And now I'll show a small demo. Is my screen visible, sir? Can you see the PowerShell?
Yeah, we can.
Okay. So first we have to move to the desktop. No, not desktop. I'm taking it as desktop. And we have to create a directory using the mkdir command. Django, any name we can give. I'm giving it as Django auto. So now we have to change the directory to the Django auto. Now we have to set the virtual environment. So I have created a directory called Django app and I have moved into it. Now I'm going to create the virtual environment, Python VENV, and I'm going to give the same name for the virtual environment for naming convention. So now we can see that inside the Django auth directory, a virtual environment has created. If I click inside that, you can see all these things. So now we have to activate the virtual environment. For that, I have to type .vnv / inside that virtual environment, I have a folder named scripts. Activate dot. So now the virtual environment has been activated. We can see that we are inside the virtual environment. Now we have to install Django. First, I have to check whether the Python is installed. So just type Python, and we can see the prompt of Python. So I'll exit it now. Now I'm going to install Django. Python install Django version 4.3. Check whether we have the internet connectivity. Then we can install the Django. It takes a few seconds. Okay, it gives a warning message like I have to upgrade pip. So I'll type that Python. Now we have installed Django and pip successfully. Next, now we have to create a project. As I have already said that Django uses the project app. If we want to create a project, we have to give a name for that project, and under the project we can create more than one apps. So first we have to create the project using the start project command. So Django admin start project Django project. I'm giving the project name as Django project. Okay, the project has been created. So now to check whether it is installed successfully, I have to run the server. So Python manage.py run server. So we can see the URL here. Copy it. So paste it in the address bar and hit enter. We can see that it is installed and worked successfully. So coming back to the PowerShell. Press Ctrl C to get back to stop the server. Django automatically installs the Auth app. Now we are going to see about the login authentication. So it automatically installs the Auth app. To view it, I'll use to view the file. I'm using VS Code. So first open the folder Django. So we can see our project, Django project. Here, navigate to settings.py. And the settings.py, come down. So we can see that before we didn't create anything, just we have done the folder and installed the Django project, Django, and we have created the project name. That's all. But we can see here that we are having set of apps, admin, auth sessions, messages, and all. So these are the built-in apps which Django provides. So there is no need to write down the app name here because it is already here. So there is no need to write the app name here. So I am showing that it is already here. To use the auth app, we need to add it to our project level URLs.py file. So come to the urls.py and type here path accounts contrib.auth URLs. And put a comma at the end. Okay. And we have to include the name, include here. So now we have provided the URL pattern, that is I'll show in the PowerShell. We have to run the server. Run server. If I type here /admin, excuse me, 1 minute. Okay, now let's make the login page. For that, I'm going to create a folder named templates. Inside the template folder, create another directory, registration. So now moving to this, we can see that we have created a template folder, and inside the template folder we have another folder named as registration, and inside the registration folder we have to create the login.html page. I'll use it as computer. Then templates, inside templates, create a so we are going to include HTML tags here. Login. Method equal to post button type /1. So save it as login.html inside the registration folder. Okay. Now we have to navigate to the settings.py, and we have to inform Django that to look for the templates folder at the project level. So for that, update DIRs. Here we can see the DIRs. Here the templates is here, DIRs. Here we have to type base dir / templates. Okay. Next, Once the user has logged in, where should they be sent? Before that, we can check the login functionalities and come to the end of the file and type login underscore redirect underscore URL equals slash. So now coming to the web shell, PowerShell. And then by migrate. Okay. Now Python manage .py run server. Okay, there one more thing I have to do. We have to change the URLs for content slash. Okay. This is the Django's admin file. Now we can create the super users.
Professor Sangeetha, it's taking time.
Yes, sir.
Can you sum it up? Because you can't do all programming right away. You will not
Okay,
have
sir.
time.
Okay. Okay, sir. Then I'll wind up. Okay, thank you, sir. Then I'll complete it.
Do you wish to sum up?
Yes, sir. Okay, I'll sum up.
Done.
So Sangeetha, we are unable to hear you. Can we go with the next speaker so that you can join us in the later part also and continue?
No, sir, I have summed the.
Okay, then, right.
Yes,
Do you want to say anything further?
no, sir.
No.
Thank you so much.
Okay. Thank you. Nice. You have any kind of clarifications to be done? You can ask in the last because we are running out of time. We'll go to the next speaker. Next speaker for now is Mahesh. Mahesh, let me introduce you and then you can take up your charge. Mahesh is he's again a hands-on expert consultant. He's a educational tech consultant in India. He does a lot of training for younger people, right from schooling to college goers and professionals he's training. He's an expert in robots, Python, drones, and all emerging technology tools. Okay. He has a very good experience on basic electronics, Arduino, wireless technologies, IoTs, artificial intelligence, designing with Raspberry Pi and web technologies, mobile app creations, etc. He has done a wonderful project on developing web application using current edge technologies like Java for a financial sector organization. Nothing to waste more time. I wish Mahesh to please take care. Thank you, Mahesh.
Thank you so much for introduction, sir. Hi, everyone. And second, I'll be sharing my screen.
Please.
Right. Okay. I hope my presentation and my video both are visible. So
we can see your presentation.
It's my video, my visuals, so my camera feed. Is it visible?
Yeah, it is visible.
Your camera, we can see you.
Okay, great. Because a small demo which we might be able to see in the demo. So that's it. Okay. Thank you. So today's session is about more concentration about the Python. So, and what I'm going to do here is I'm going to scratch a little bit in OpenCV. And for some of you may know about what is an OpenCV much more detailed, but for those who are new or beginner, let me say you it's about a computer vision. Let's say how you can provide or you can give an intelligence to the computer to see something and to get information through seeing. That's nothing but a camera, right? For an example, we all have a mobile phone, and you might know the option like face, like if you show your face, it will just open your screen. It's an face recognition, right? Comes under the OpenCV, but is that this kind of technology like more like recognition does comes under the OpenCV? No, actually you are using like a computer vision or something to do with the image in all day-to-day activity. For example, in WhatsApp, most of you might take the image to share, but before sharing, you might write something on the image. Have you noticed you can edit the image? You can write something upon the image. You can draw a circle on the image. You can add two more images together. So you do something with image, right? So we call that image processing. That and also the video processing. So the both comes under the topic like a OpenCV. It's a computer vision where we use a Python to do or to get an information from an image and video. So this is what we are going to do today. And so before I start the session, let me tell you the agenda, how I'm going to follow. First, like 2 to 3 minutes, I'm going to tell you like, or 5 minutes, I'm going to tell you what are the softwares and package I've been using for this demo first. And second, I'm going to give you a little bit idea about fundamentals of computer vision and why Python. Why computer vision with Python? Why not with other languages? So that little bit of information I'm going to give you, like what is so OpenCV and Python together. And third, we are going to start the session. So around it might take altogether like 30 to 40 minutes at max, not more than that. So first, let me tell you what are the softwares we needed to, what I'm going to use it to do this activity. And so I'm using a PyCharm, which is editor where we are going to do the code. If you want any other editor, you can choose. But if you are a beginner, then my opinion is go with the Python. It's easy and to do. Okay, I'm going to share this link, everything here. If anyone needs, you can just you can take from here. Okay, otherwise later I will post the link. Okay, where you have all the links and details over here. I'll post my Jamboard link to you where you can access it. Okay, and the second software which we are going to use is a Miniconda. So it's a Conda, it's like a package manager for the Python. We are going to use Miniconda because we are going to use a package called face recognition. So we are not only using the package OpenCV, but also we are going to like fuse the face recognition and also the OpenCV to do a small demo, right? So these are the tools we are going to use. And while installing, what are the things what you wanted to know? Let me just tell that. This is just a thing. Yes. One second. Okay, great. So while the PyCharm can be installed so easy, if you wanted to know how to install PyCharm, you can go to the YouTube and see how to install a PyCharm. It's a very simple, straightforward process. And the same Miniconda. So while you're installing the Miniconda, you want to just do few things. You want to keep in mind few things. Let me tell you what are those. You want to know this address. Okay, you might give some destination address. You want to note down this address because we have to do some configuration to that. So first thing to note down this address. And while you're installing, you might ask with this two option. You can first mandatory have to check mark the first, but the second is it's okay. If you check mark, it's okay. If not, it's fine. So, but the first one is must check. So if you do this, most of the configuration will be done good. Okay. And then after doing the configuration, after installing the both, what you have to do, you have to install a packages. So let me show you where you have to install the packages, file, setting, and under the project, my project name is a webinar and Python interpreter. And in Python interpreter, you might see with a lot of it. It takes some time to load. Once it load, all my packages. And there are two important packages you want to install, which is OpenCV and face recognition. But here there is a catch. The face recognition cannot be installed this way. So I shared the link for both. Like this is the okay Conda. Okay, after installing Miniconda, you want to install this. Okay, and pip install OpenCV. Where you have to do this, you want to copy that tool link. Okay, and you wanted to either you can use it for installing the OpenCV. Otherwise, one second, there is an option here. Here, terminal. Okay, in the terminal you can paste it. So if you just paste it and just enter, all the necessary library will be installed. Okay, this is the minimal configuration what you needed to make work on this activity. Okay, so now second agenda, what is a computer vision and why Python we needed to make the computer vision easier. Okay, see, first you want to understand this, the implementation of technology is not much tough always. It's so easier, and it becomes easier when you understand the core of any technology. For an example, Python is a programming language used to implement a technology like OpenCV, right? Now, until or unless you understand the core concept of OpenCV, you may think that, okay, it's something like Himalayas, it's something we cannot catch hold of. It's not that. Always keep this in your mind that a technology, any technology, there will be a core. Straight away, just go and scratch the code. Then don't just learn the side feeds. Okay, it's a waste of time. So I'm just going to give you the only core what you wanted to know. Okay, so OpenCV, it's a computer vision, right? So when I say computer vision, you don't want to think it's much of other things. Okay, you can broadly classify the computer vision into two: image or a video, right? That's it. You just think. You in your camera, while you're opening the camera, you can do only two things. You can take an image or you can take the video. So that's the computer vision. So how a computer see, either through image or through a video. Okay, these are the two things. Okay, so what is a image? What is a video? So this is the only information you wanted to know. If you really understand that, then computer vision can be done easily with the Python. So my focus now for the next 5 minutes to make you understand about what is an image and what is a video. Let's start with what is an image. I have an image in my desktop and that is this. Okay. I'm going to open this image through my editing software. And now you see the image. Now you see something the same, like as usual, whatever you see like a human eye, and that's the same thing you see through the here. But do you think the computer, or you can call robot or a system, anything, do you think it see an image the same way exactly how we see, how we human beings see? No, not. Let me give an example. This is what you see the image, right? But you know how the computer knows the image. I'll zoom it. This is how the computer knows the image. A pixel. So a collection of pixel in a rows and columns, that's make an image. A computer doesn't know what image it's going to appear. It doesn't know anything about that. But the computer knows only one information. What kind of information is that? What is the pixel? And what is the color of each pixel? That's it. Okay, so what is an image then? So image is just a collection of, one second. Okay. Image is just a image. If you just consider an image, it's just a collection of pixels in a rows and column. I'm sorry, I do have a pen. Actually, it ran out of battery. I didn't have a time to reach in, so I'm just drawing out my hand. Please excuse for that. Okay, so what is the image? It's just rows and columns of pixel. Okay, that's it. So each pixel, what is the each pixel? Oh, the each pixel has its own color. That's it. So when you put all the pixel together, we see it as an image. That's it. This is an image. So image is a collection of pixel. What is a pixel? It's just a small area separated by specific color. Okay, now what is a video? It's a collection of images. You might know about a name like frame per second. That might be very similar to you. So it's nothing but how much images that you can put together to make a single second. Okay, that's a video, right? So a collection of images is a video. So if you just go backward, video, it's a collection of image, it's a pixel. Now we will learn little more about this pixel, right? We will try to understand little more about this pixel. If you want to understand more about the pixel, you want to understand something about the color space, right? Something about color space, but we'll hold on here. Until this, we will do some demo. So what I'm going to do here, I'm going to write the code. Actually, what I did is I have all the code for this activity in my previous files because I don't want to waste the time. So what I do, I just go and copy and paste and I will show you. I hope Krishnan sir will share this as a video link where you can learn in detail through internet, right? So I'm not going to explain each and every line of code, which is impossible in a short time of time. Okay, so I'm going to space main display image. Okay, so first thing what I'm going to do is I'm going to use the package. And those who doesn't know what is those who are new to the Python, okay, I told that I will be telling you something that why Python, but still I not explore that. I will do that later. I didn't forget that. I'll tell you. But for those who doesn't know what is the import, I will tell you in the forthcoming minutes. Okay, and what this line will do is this is a package we are importing in our own file, and I'm asking to read the image. Okay, I have an image in the same image I showed you in like a gallery, right? The same image I am taking from the location. You want to give a location, and for the starter, I just wanted to know you want to use a raw string. If you want, you go and search in the internet about raw string in Python. You want a specific raw string to make this property. You go to the property of the image and you have this image property, the location, and you can paste here. Okay. And then I wanted to take this image and I want to show that in the file. Okay. In the Python file. Okay. So what I do for that is, these are the standard codes. Okay. Which you can also work on with. Okay. So now what I did, I give a particular location file image. Okay. And I'm asking it to display. Okay. Now a little bit, I'll explain the code part. So CVT is a package. If you know about the Python, what is a package? It's a collection of methods. What is a method? It's a collection of lines of code. See, I'll make it little clear for who doesn't have an experience in code at all. Okay. See, what is the programming language? It's nothing but giving an instruction to a computer to understand. Okay. If you want to give an instruction, it's a single piece of line of code. Okay. So let's say this is a line of code that you are giving some instruction. Okay. So now what I can do, I can catch, or I can take all the line of code and I can put in a container. Okay. And I call this container a method. Why I do that? For example, if I write this line of code to solve some problem, I can share with you. And what you can do, you can use the same method to save the time to solve the same problem. So it's like a reusing the code or saving the time. You can call anything, but this is for one method. Okay. Now what I do, like a computer vision, if I wanted to do some operation on a computer vision, let's say I want to blur the image, it's one operation, it's one method, it's one functionality. I wanted to find the edge, it's one method, it's one functionality. If I wanted to flip the image, if I wanted to rotate the image, if I wanted to do some operation on the image, it's a different methods. So what I do, this different method I put in one single file. What I do, different methods. Okay. Different methods. This is method 1, method 2. I'll name some method. Okay, we can name some method. That's not an issue. And this collection of method is what we call package. So package, it's a collection of method. Okay, now this package is what we call CV2, which is a package which we use to do work with an image processing and video processing. So now coming back to the code. So I told what is a CV2, right? It's a package. And what a package does, it has a lot of method to do some operation with an image or the video. One such operation is IMRead. So what IMRead, current has gone, I think. So you might see me little dull. I'm sorry for that. IMRead, what the IMRead does is it will read the image and it will store in a variable. And for your information, this variable has to be particularly in NumPy n-dimensional array. Okay, NumPy ND array. Why it should be ND array, I will explain that to you. And then you can show this image. Again, it's another method call where this method is available in a CV2. So you have to access by cv2.imshow, right? Now let me run this and show you how it works. The image just appear, right? It's so simple. So this is a normal thing. Okay, now I wanted to know what is a pixel in little bit detail, right? That's what I told you, right? Understanding the pixel. So to understand the pixel, I told that you want to understand the color space. Let me tell you why. Okay, first let me tell you what are the different color space available. Okay, like grayscale. You might know about the grayscale very well, right? In olden days, you might know about the black and white TV, right? You know very well an image appears or a video appears on the television, but you cannot see in a color. Why? It's something from white to black. So it's a gray. It's actually white and black mix. We call gray, right? We call that grayscale. So each and every pixel, even though it's a color, okay, listen to me, even though it's a color, when it comes here, it will be changed into grayscale. I will show you how it change into grayscale. Okay. There are a few methods that you can use to make it grayscale, but I'll do it in a shorter way. If I use the 0, okay, you can see that image as a grayscale. The same image, what I showed you, see, now it turned to grayscale. What is a grayscale then? It's just a pixel. Each and every pixel will take any value from 0 to 255. I told you what is that? An image, it's a collection of pixels. For an example, if this is an image, it's a collection of pixels. This single pixel will be any value between 0 to 255, any value. We doesn't know. So now what is, I think, I'm not sure. I think the white 0 is more white, I think. It could be reverse. I forgot about that. Okay. And 255 is more black, I think. Okay. So more the value it is, the more the black, the less the value, the less the, it's more the white. So it's combination of black and white. So this is how it's stored. So now I'm coming to the pixel. See here. Now it's problem is solved. Why the problem is solved? In a grayscale, each and what is the image? It's a collection of pixel in a rows and column. So each pixel in a particular rows and column has a value, right? What value in a numbers? So 0 to 255. It can be 244, 232, 282, right? Now this become easy for a computer to store. Why? What is a computer? It's what is a Python can do? Now here comes the Python. So now we have OpenCV does this for us. What it does, it take the image and it store in a variable in the format n-dimensional array with to store the numbers. Okay, now I'll show you. I'll print this and I'll show you print. Okay, and I will show you the image. Okay, you can see here below. So as I mentioned, that's it. That's it. Each and every pixel is numbered. See? So we got the number. So now you tell me. Now I told you video is a collection of image. Image is a collection of pixel. Now each and every pixel is made up of number. So when we store the number, can we able to process the number? Of course, it's possible, right? So that's became image processing, and that becomes an image video processing. Now let me give an example of image processing. Okay, I'm going to skip one thing called RGB. How an RGB, okay, the color is an RGB color which can be stored in the one second. One second. I'm sorry. Okay. And RGB is the color. Okay, so when it comes to storing in the variable, it will store in a 3 different value. Okay, for those who, this is a little bit you want to think. Okay, for an example, each pixel, if it is a colorful pixel, okay, if this is an image, okay, if this is an image, if it is a colorful pixel, now you can ask me a question. This is not a gray. Okay, grayscale is going to take a value from 0 to 255. Now let's say this pixel is colorful. It's an yellow, red, orange. So how do you store this? Okay, the CV2 played this with very well. What does it do is, we know that we have to select this color. So we are going to apply an RGB model, a color scale called RGB. There are a lot of other color scale which you can refer in the internet. We are going to select an RGB. So if you know what is the red value, if you know what is the G value, green value, if you know what is a blue value, some value, you can find out what is the color. Okay, so think of reverse. If you know what is the color, it will have some value in red. It will have some value in green. It may have some value in blue. So this value, collection of value will say, collection of number will say, what is the color in a single pixel. So what the CV2 will do, it will take one pixel and this pixel will be stored in the 3 different numbers. One for red, one for green, one for blue. So first cell in the green, first cell in the blue will be all numbers are taken together to find out what is the color. So this is how a computer vision store any pixel in a variable. That's it. So if you really understand, then the forthcoming things is going to be very easy. Okay, so I explained up to now. I explained what is a video. It's a collection of image. Image is a collection of pixel. Pixel is a one specific color. Pixel can be any color scale. It can be grayscale or the colorful. If it is a grayscale, it is going to have only value from 0 to 255. If it is a color, we can apply any color model. It could be orange or RGB or CYMK or something glab it comes. I forgot the name, right? So based on that, you can give a different, for R and G and B, you can give a different value where it will be stored in the. Okay, if you wanted to see the difference between the what is that, the grayscale and the color, I will show you that too. If you feel that you want to see the change, okay, I will copy and paste this where you can do this and you can research this later. Okay, but you can see here there is a shape. Okay, in the image there is a list attribute called shape. Okay, which we are going to use to get the height of an image, width of an image, and the dimension. What is the dimension? Is it a grayscale or the RGB? Now let's run the file. Now you see here, this image is the grayscale, right? Now you see the total pixel in a height, it's a 440. The total width of an image, it's a 330. So we can find out how many total pixel available in the image. To construct an image, how many pixel is that? It's a multiplication of 440 into 330. But what is the dimension? It's a one dimension. Why? We are using the grayscale. Now I change that into RGB, right? Now you see here what happens. The same code, everything same. The width and the height is same. But what happened? 1 second. We can see below, right? I hope. It becomes 3. What is that 3? I told you. Each pixel will store in 3 different boxes. Why? Or single separate value, G separate value, blue separate value. All 3 go together and point out what is the color for a single pixel. So I hope you understood a pixel in little more in detail. So a computer vision with Python, we are going to play with the numbers, play with the pixels to do some operations such as blurring, such as finding edge, and some complex or some advanced like finding the face, recognizing a face. Okay, this is the 4th thing we are going to do. I'm going to be a little faster. Okay, so I'll take this all basics. Okay, now I told you we got an image. Okay, we got an image here, right? We got an image here, and we are displaying the image here, right? So we have an input, we have an output. Now we are going to do a process in between. I hope you understand what I'm trying to say. So we have an input image, okay, input image, and we are going to have an output image. And what is the process that we are going to do to make the input image to the particular output image? This we call function. What function I'm going to apply? Okay, first thing I'm going to make it blur. Okay, you know the blur, right? Making the screen blur. Do you think that I want to write a huge lines of code to make it blur? No, that's not. Thanks for the CV2 package. So what does the CV2 package does is to make a blur, we need some lines of code, right? Those lines of code are given in a container called methods, and that method, it's named as blur. Okay, so this is the name. Okay, this is the method. So what I do after the image, I just apply the blur. See here in a CV2 package, I have a method blur where I'm giving a parameter image, and I'm going to give some like neighbors, which you can search about the parameters of the blur later in the internet. You understand it. But if I, so this image, the source image, what is the source image? It's not the image what you see. It's a collection of pixel. It will be in the numbers. So that is given in the feed as a parameter. That is made a operation. What is that? So that we storing in a variable called blur. So this blur we are going to display here. Okay. So this is not the, okay, let me do one thing. Let me put the both. Okay. So this is the IM show of the original image. Let me put a blur image as well. Blur. Okay. Now let's run and see. Okay, you can see the blur, right? It's very easy. It's one of the operation. Okay, do you think it's the only operation? We do have a lot of operation the same. Okay, let's say edge detection. Let me make it a little faster. Okay, it's all same. Okay, just to make you clear, I'm just giving a little bit of more information. Okay, I'm going to give here edge. Okay, and I'm going to name it as edge. It's not necessary, but still I'll name it. Okay, and you see here the edge is found. See, it's very cool, right? So we just wanted to give a method. So what is our responsibilities? When we know a little bit of Python, we can easily use the CV2 and we know what function I'm going to apply. And that function definitely has a method name that you have to find in the internet. You can go to the OpenCV documentation, you can learn and you can apply. So this is about an image. Okay, can we do the same with the video? The same approach, right? We will do with the video just for your understanding. I'm copying this. I do have already with the video, the same blur. Okay, this is about the image, right? I'm going to do the same with the blur. Okay, so to make with the blur, okay, this is a normal image. Okay, so I will first run this and I will show you how it works. To do that, I wanted to turn off my video on this on the here. Okay, now I will just run here. Just you can see on the screen. Okay, my video will be appearing. Okay, so what happened is the Python take the video and it will display here, and I want to press the escape button to cut this. Okay, let me explain a little bit of this, a little bit. Okay, so video capture is the class. Okay, those who doesn't know what is a class, please go and refer it. It's not a method, it's a class. This class has a lot of methods such as read. So what I'm trying to do from the camera, we are reading an image. That image I'm going to make it as a frame, and I'm making it in a while loop. And for those who doesn't know what is a while loop, a set of code will repeat again and again and again and again until a condition becomes false. So here the condition will become false, or the loop will break when I give escape button. Okay, you can all see this later in internet. It's like a extra fit I mentioned earlier. This all you can learn on your own. Okay, if you have an interest really, so you can learn on its own. I'll just tell you, this is used to get a information from the keyboard. My keyboard, when I press escape button, the ASCII value of the escape button will be 27. So if the 27 is matched, then it will break. The while will break, then the screen will be disappearing. Okay, until and under each, see what is that? If you watch it carefully, I'm reading only an image, but I'm making the image to appear again and again, which seems to be a video. So video is an illusion. It's like a collection of images. An image is also an illusion. It's just nothing but a pixel. A pixel is also illusion because it's nothing but a number or data, right? So that's it. That is the only thing I want to break down. Okay, and now in the video, if I wanted to make a blur, right? So what I do after reading an image, I just go to the blur. Okay, and I'll take the blur operation, the blur method, the same whatever we did earlier, and I paste here, right? I wanted to give the frame here, and I'll copy and I will paste here. Okay, and the blur is done. Right now you want to display the blur, right? I will I'll put here, and I'll ask to go with the blur. Okay, it's not an original image, it's a blur image. Okay, you don't want to get confused. So I'm not going to display the original feed. I'm going to just display the distorted like a blur image. Okay, you can see my video will be blur now. So what I did is actually I taken each and every frame or the image from the computer. Okay, and I'm making it to blur that image. I'm not making the video blur. Don't make that a mistake. Each and every frame is blur, and as it is looping again and again, it seems to be a video. A video is just an illusion. Keep that in your mind in a computer vision. Okay, and then we finish with the blurring. Okay, so you know now you may get a, what I'm trying to say is either it's an image or a video. You want to make an operation. Operation can be like operations can be like basic methods of transmission, like a canny, which is nothing edge, and the blur is nothing but like a blur, what I showed you, right? Resize, you can resize the image, you can make it small, scale, rotate, you can rotate the image. I hope that you all done this operation in your mobile phone, right? So that's the same. And then I'm going to make a face detection. I'm going to go it a little faster. So I have a code, okay, and I'm going to paste this here. Better, I'll explain a little bit. What I did is to make the face detection, okay, I need another classifier, which also available in the CV2. Okay, this is a classifier. If you have ever heard about like a little bit of data mining or data science, you know about the classifier. It's a technique of data mining, classification. Okay, so it's a cascade classifier. Okay, in the cascade classifier, I want to provide the model. And what is this activity is? This activity finds the face in an image. I'm doing it only on the image. I think this is I'm sorry, this is on the video. Okay, this is on the video. So in the video, if it find out a face, it will put a rectangle box on it. See how to understand face is something a default one, right? If human face particularly, you go throughout the world, it can be any country, any race, anything, any age, the face will be same. 2 eye, nose, mouth, or like ears, the frontal face will be same. So that is a model called frontal face. So that frontal face I'm getting over here. Okay. And you can search on internet about face detection using the cascade classifier. Most probably you get the same code. I did a little modification, but most probably you get the same code. And what you want to know is, what is this model? What is that HAR model? HAR model is my face. So what they did, the designer who taken all the points that say that is the face and they put it in an XML file. Okay. And that I'm giving to the classifier. Okay. So I made a classifier ready with the face as a points. Okay. Face as a model. Okay. Now what we are doing? We are going to the same procedure. I'm making a video capture to capture the image from the camera feed using the OpenCV2 package. And inside the class, I'm using the read method where I'm reading the images frame by frame. And I'm converting the color. See, this is a new method that I'm going to introduce you. A convert color. I told you there is a color scale. When the image is taken from the camera, you will get BGR. Okay, not RGB. Keep in your mind, it's a BGR. Okay, so the BGR value, each and every pixel, I'm asking you to convert to grayscale. So you don't want to do that. Again, you have a method to just apply. Okay, you want to say what you want to apply. You want to convert the color scale of the pixel of what frame you have to have in the first parameter, and second parameter you have to apply from BGR to gray or RGB to like YMCK. It's all default. You can just select it by writing the CV2, which is all available in the CV2 package. Okay. To detect the face, what we are going to do is detect multi-scale. It's a method. Again, where is it available? In the face cascade classifier class. It's a class where the method is available. I'm giving some parameter like input image, which is made a gray. Okay. And these parameters are like additional parameter you can go and learn in internet. Okay. So what the faces will have, the faces is a list. If you know the Python, a concept of list, faces will have a multiple list in it. It will store a multiple list in it. Okay. And we will make a rectangle box around it. Okay. I don't have a time to explain how it make a rectangle box. Again, making a rectangle box on a video, it's because of the CV2 package. And I'm going to show the target image. Let me run and show you. So this is a common algorithm. You may have all your mobile phone camera. When you take a camera, you know, while you're taking a selfie. Okay, now the problem is, wait, I think the model is not face. That's a problem. 1 second. See, the model is HAR cascade smile. Okay, okay. 1 second. Now I will tell you how to take that model. Okay, because I did it wrong. When I copied the code, I made the wrong, but that's fine. I'll try to fix it. So CV2 here, I wanted to go to the just 2 minutes. It will not take much. Okay, and frontal face, and this is a frontal face. Okay, and properties and frontal face are not alternative. 1 second. Frontal face, front. Okay, I think this will be better. Properties. This is a model. See, all these models are available. Number plate, you can take a number plate, a smile. You can find out the smile, lower body, upper body. You can do all this over here. Okay, I just wanted to change the frontal face model over here, which I did now, which I'm running it again. Now I hope you can detect it can detect my face. But also the face, false face also possible. Okay, but now it's perfect. So what is happening? In an image, each and every pixel, the point which already given in the model is matching with my input image. And if that matches, okay, and it makes a rectangle box as we did the code. It's simple. Krishnan sir, do we have a time to take one more activity? We will take another 5 minutes, or can we wind up?
Issues.
If it's
No issues. No issues.
okay, okay, thank you, sir. Okay, this is a face detection. Okay, and finally, the last activity, which we are the last thing what we are going to see is a face recognition. This is a little more advanced than earlier. Okay, what is a face recognition is? We have to give a target image of a person. I'm going to give my target image. Okay, but I'm not going to use a CV2. I'm going to use a face recognition package, which is a separate package. To install it, you need a conda, right? Which I details, or I'll share the which I will share the link as well in the chat after this. So in this face recognition, what we do, we give the target image. In here, I given my target image already. See here, the target image is here. I will show you In my desktop, what is my target image? My God, desktop. Okay, 1 second. Okay, this is the target image. Okay, this is the target image. Okay, I think I have taken some while I'm doing some class earlier. Now you can see me. Okay, of course there are few modification, or I can also give this, no issues. I can also give this as a target. It is a little bit of different, right? I can give that. Okay, so what I'm doing is I'm using the face recognition library. It's not a CV2 library, and I'm getting the file. What file? Target 2. I'm not going to give it the target 1. There was another image, right? I given that because right now my face and that face look little different, right? Even though I'm giving that. Okay, and then I'm asking the same face recognition library to encode it. You can ask me now, what is this encoding? See, you all know that even though we have billions of people in the world, each and every person face is unique by some way, right? So if you go with a mathematical, there will be a points in a face which will be the distance of each and every point connected will be vary, right? So we are going to take that points and we are going to store here. That we'll call encoding. Usually it will take 128 different encoding points to compare with other image. So I have given a target image of mine and I change into encoding. So how much point from a face it's has taken right now from the image what I shown? 128 points. Now what we have to do, the following code is simple. As usual, we are going for the video capture class. We are going to use a method read from the video capture, and we are going to get the image, which I am going to store in a variable called frame, which is a NumPy n-dimensional array type. If you want, you can refer what is that internet later. And then I'm giving it in a method called location. Okay, what is this location does? That location also available in the face recognition. What does it do is it exactly gives us what is an exact location in image. For an example, if this is the image, okay, and this is my face, what the algorithm will do is it will give us this point. Okay, what is this? X and Y. And also it will give us what is the X and Y width and what is the height. See, now we got all the information of the location. I'm sorry. I'm very sorry. This is another algorithm. I confused with that. I'm very sorry. This algorithm works a little different. It will give the position this way. From the top, what is the height? From the right, what is the height? From the bottom, what is the height? From the left, what is the distance? So this distance, right? If you know, see, image, it's a static one. The image frame, the size, frame size is the static one, right? So now if there is a face recognized and it's a face detection. First step is a face detection. After detecting, we are getting the location. Okay. So this alone now we have taken. And what we are going to do, that face alone, we are going to do encoding. Okay. What is an encoding? As I mentioned, encoding can be points, a 28 different set of points that each and every, that's how we differentiate each and every face. Okay. And that we stored in the unknown face encoding. So we have a two face encoding, target face encoding and unknown face encoding. And here I wanted to tell you, you may ask, Mahesh, in a video, not only you could be there. Will there be any other person? Is it possible? Yes. In the same video, I can have a multiple person in a video, right? So all the face will be stored here. And for all the face in my frame, there will be an encoding. So this is a list of encoding for a different faces in a same image. Okay. So that's you wanted to know. It's not only one image could be available, because video when it take, it could be a different thing. Okay. That's a point you wanted to know. What I'm doing now, I'm going to make some for, okay. If there is a no image in the frame, okay, we are going to say no face detected. It's so easy. When there is a no image, I'll say no face detected. When there is an image, then what we have to do is I'm making the face encoding iteratable. So what will happen? Each and every image will be iterated here, and that each and every thing will be compared. So compare face is also available in the same face recognition, which I'm going to compare with the encoding of the one which we got from the video feed, the one with earlier frame, whatever we given over here. Okay. So the thing is, if my face is detected, I will say face detected, it's on. My name is Mahesh Anand again. Okay, and face is detected. But if it's not me, I will just say it is not on. That's it. Okay, so this is the very simplest code. I try to explain to my best, but of course, I say it again, I'm just trying to scratch the code. If you understand the pixels and the image and video, you can, and the packages, whatever we are using, you can easily go and refer to the internet, right? So finally, I will just run this and I will show you how it works. Okay. Now, I would appear, okay, I'll just put this little here. I would be appearing on the screen right now, frame. Opening the frame, the video will be little, see, I am appearing on the frame. So as I'm appearing on the frame, it says it's on, and okay, I'll move out of the frame. Okay, it says, of course, my hand, it doesn't appear. Okay, mobile phone, it doesn't say, it's a no face detected. Okay, now I'm appearing. Okay, it says it's face detected and it's on. And then finally, I like a character very much, which is a Harry Potter. So I will show him in the image, in the camera. Oh, it says face detected and it's not on. Okay, it's beautiful. So it is able to recognize, not only detect the image, but also it recognize the image. So this is the basic of image processing or the computer vision with a Python. So Python is a tool where we just process the numbers, and image processing is just a collection of pixels which we use a Python to process those numbers. So that's it, sir. So, thank you so much.
Thank you. Thank you. Mahesh, there are some few questions you need to answer.
Oh, I haven't noticed that. I'm sorry.
No problem. We'll share it to you now.
Okay. 5 applications. Mention 5 specific applications of Python. So actually, I'm really not exactly aware of what is the exact question of the application of Python. But let me tell in a different way why Python. I'll put in a different way, sir. Actually, Python is a very simplest way to do. And because of its completely object and classes, if you know about the Python, we don't have anything such as a data structure. Oh, sorry, like a data types. It's all classes and objects. So what happened? There are many libraries available. And someone has asked way to be applied in a drugs discovery and some. Okay, I'm not much in that area, but I have done like a genomic, gene informatics. So I have done a few projects earlier. When I do that, so our each and every gene can be again converted to the data. So what I'm trying to say is anything that can be converted into data and numbers, right? That can be exclusively, we can do anything with Python. Why? Because Python can interact or integrate other technology. Let's say computer vision, one of it. Let's say machine learning. Let's say like web frame application like the Django, like other Sangeetha ma'am has taken. It can able to connect all the technology. The reason is there are many experts or the companies who provide their own packages for the Python. I'll just give you one example. I too already teach Tello drones for the students. To control this Tello, there is a package in the Python. So what we do actually is the answering to the question, irrespective of the application, if that particular aspect of research has a library added, then of course we can use a Python. So that would be my answer, sir. What aspect of Python is relevant in this area? In what ways can Python be applied in drug discovery of them? I'm very sorry, sir. I'm not into that area specifically to the drug analysis and the like sciences. So I'm more about engineering area like physics and like engineering and like electronics and like aero modeling and like something like that. So not to that area. And
thank you, Mahesh. The first question was answered by Professor Mannat. She has already said, it can be used in data science, game development, web development, networking, web scraping, and many more. Okay, when she does a talk, more clarification can come. Now, can we go on to the next speaker? The next speaker is Professor Mannat. One second. Okay. Professor Mannat Doultani is from Bombay, now called as Mumbai. She teaches in VESIT, Mumbai. She does a lot of hands-on projects in many of these emerging technologies. Actually, as a professor, she handles structured programming approaches, database management, analysis of algorithms, data structures, operating systems, web technology, and many other things. On practicals, she handles Python, operating systems, shell programming, etc. Not to waste much time in introducing her, she's a very profound teacher and implementer. Welcome you, Dr. Mannat.
Thank you, Krishnan, sir. Thanks a lot. Am I audible properly?
Yes, yes, you are.
Yeah. So can I share my screen?
Please.
Yeah. So to begin with, I'm here to brief you regarding the networking part of the Python. Very simple steps we need to follow. We need to study only one single module of socket and we are done with it. So I've taken an example of chat server between client and the server part. So I'll brief you regarding the same. Is my screen visible properly?
Yes.
Yeah, thank you. So regarding networking in Python, we need to know some basic terms and terminologies. Okay, so we have heard regarding protocols. Many of we know already what do we mean by protocols. Those are nothing but the set of rules to be followed. So when it comes to networking, so we need to follow some rules. We abide to some rules that we need to follow while we code for the networking in Python. Okay, so the basic protocols, basic set of rules provided for networking in Python or networking in general are the two set of protocols. One is TCP/IP and then other is UDP. When I talk about the text, web pages, HTML text, web pages having lot of text content, we more tend towards the TCP/IP protocol, which is nothing but transmission control protocol, internet protocol. And when we talk about audio, video, images, when we need to send some, nowadays it's a social media time. So images, images we want to share, audio we want to share, we use UDP protocol. That is nothing but user datagram protocol. So first we'll see how these protocols work in brief. Okay, so when I talk about TCP IP protocol, there are basic 5 layers. We stand above, or we are at the application layer. Application layer collects the data from the user. So we are giving chunks of data to our system. Now we have to transfer this to the receiver's end. So in between is the TCP IP protocol set of rules which handles everything. So I'll take an analogy of booking something on an online website. So for example, I have ordered a parcel from say Amazon. Okay, so I am working on the application layer. Now what's happening next is Amazon collects all the orders and numbers them. Okay, this is packet 1, this is packet 2, packet 3. So TCP does what? It converts my data into packets and those packets are numbered. Okay, so the job of the TCP is to divide the data into small packets, because at one single shot, your data cannot go to the receiver's end. There are some limitations on the data size. So the data is being divided into packets. Now these packets are again, like if you order a parcel, it does not comes to you as it is. It is wrapped inside an envelope and every information is written from where you have ordered, where it has to go, each sender and receiver information. Same is the job of the IP layer. IP layer puts this data packet into a frame. Now, frame consists of information like what is the packet number, who is the sender, who is the receiver. So this enveloping part is being done by the IP layer. Next comes the data link layer. This is nothing but your courier service type thing. Okay, so data link layer basically does the transferring ka job from the warehouse to the receiver's part. So that particular taking of the data, moving of the data, a step head is done by the data link layer, and the boy which comes at your door to deliver the packet, so that particular thing is being done by the physical layer. So physical layer actually delivers the data at the receiver end. So this is how your TCP/IP protocol works. Now, why are we going with text and TCP/IP? So text has to be arranged in stream of bits. For example, you have a paragraph of 10 lines. It won't work if I pass first line and then 10 line and then the 10th line and then the second line. So it has to be one by one in order. Okay, so the packets have to be delivered in order, first, second, third, fourth. Okay, so it is it has to maintain some kind of order. You cannot miss a package. You cannot say in TCP a packet is lost. No, it is very reliable in nature, TCP/IP, and it keeps tracks of the data. It is connection oriented protocol. Whereas when I talk about UDP, so we can imagine that there is an image. Okay, now you might have, while you're working on the internet or downloading an image or opening a file where you have lots and lots of image, it may happen that okay, when the page is loading, half of the image is coming instantly, and later on it is taking time to load the full image. That too, it may happen that one corner of the image has come first, then the last corner, and then the second middle one. So that's completely fine in the image. Or it may happen that a clear image was sent and the blur image which I'm getting because the loss of data has been taken in the data transfer. So that is completely fine with the image part of thing, because we can recover that later on at the client edge. So UDP is not that reliable. It is it is basically working for your audio, videos, and images. So how does it work? Same thing when you are giving a large file. Okay, so on the network, that file is being converted into the datagrams. Now these datagrams are not numbered. The order is not important in this particular type of protocol. So file is split up into datagrams. Now via the communication channel, via your internet, at the receiver ends, these datagrams are again collected one by one. Okay, and it may happen that one or two datagrams are lost in between, but that is completely fine. We can recover that image on the client side. Not the complete things are lost, but we have the chance of recovering at the client side. So hence we say that UDP is not that reliable as compared to the TCP. So TCP is used for the text kind of thing, and this is used for image kind. So these are the two main protocols on basis of which we are going to further go with networking in Python. Okay, so some basic differences between TCP and UDP. So this is one-to-one connection oriented protocol. Here we go for unicast, multicast, and broadcast kind of thing. Slower but more reliable transfer. As you can see, it is faster, but you cannot guarantee that complete things will be transferred. So file, FTP, web browsing, these are the applications which you can do with the TCP. Live streaming, online games, we can go with the UDP protocol. Now, coming to Python. So Python, what do we mean by socket? If you are new to this, I just explain in brief what do we mean by socket. This is a server and these are the clients. Now, there is some connection between a client and a server. So they join hands over here. The point at which they join hands is called a port, and each port is being numbered. This port is again named as socket. Okay, so port is nothing but, or socket is nothing but the point where your client and server meets, and that particular point is being given a port number where your server will connect to your client. Now, there are many port numbers assigned to each and every client on which they join. Okay, so 5,000, 4,507, these numbers are nothing but the port numbers. Now, if you are working or if you're programming regarding these sockets, it becomes socket programming, or you can say network programming. So that is how the socket programming is named in Python. So what does the Python provides to you? Python provides a module called socket. Socket is the module where you get inbuilt functions and say terms or the variables which you can directly use, directly import and write the code. Very, very simple. Before we go and write a simple code, we need to understand the functions, main basic functions provided by the Python socket module. Okay, so when I come to the networking part, we understood what is a port number. Note for caution is you cannot use port number in your program from 0 to 1023. Why? Because these ports are already reserved. For example, if I am giving port number 21, so it's already being reserved for FTP protocol. If I'm using 23, it is being already reserved for Telnet, 25 for SMTP. Similarly, I cannot use the numbers from 0 to 1023. These 1024 ports are already being reserved. You can assign the port number from 1025 and so on. Okay, so we'll come to that part. So these are some of the port numbers whose application or service I have listed already in front of you. Okay, now, so if you can see on the right bottom corner, there's something called S equals to socket.socket. Now, what is this thing? Socket, the first socket word is nothing but the module in Python. Inside that, I have a function called socket. And to that, we are passing two arguments, the address type and the stream. Okay, so basically address family or the type. Now, what do we mean by that? Address family is nothing but the version of the IP protocol, Internet Protocol version 4 and Internet Protocol version 6. I hope you know the difference. IPv4 is nothing but the address part. Now, you know each and every client has an IP address through which I can identify a machine. Okay, so when I talk about IPv4, the address part is limited. 128 bits are being used for defining the address part. Okay, and when I talk about IPv6, I get the more space. Like it is nothing but 256 bytes ka uska, you can use that much bits for defining the address. So you get more space to have more clients on the internet world. So these are the two address family which I can address. So for IPv4, it uses the term called AF underscore INET. So AF stands for address family. This is INET, that is internet. Okay. And IPv6, that is IP version 6, is for address. For that, we have AF underscore INET6, that is version 6 ke liye we have this particular version term to be used. Now, next, type means what? Like which type of protocol you want to use. Either it is TCP or it is UDP. Which type of protocol? So if you want to use TCP, which is a default one also, you have to write sock, short form for socket, underscore stream. If you want to use UDP, you have to write sock underscore dgram. Dgram stands for datagram. Okay, so when I will write the program, I'm going to make, or I'm going to have an object of my socket module, which is S. So S is of which type, which address family, and of which type I need to specify that. By default, it is IPv4 and TCP/IP, that is sock_string. Okay, so if you go for socket programming in Python, the two things which you're going to have is a server and a client. Now, which all functions you are going to use? Both server and client are going to use the socket function to have the socket object. Okay, so that's common to both of them. When I talk about server, now the first function which comes is bind. What do you mean by bind? As you saw in this diagram, the server needs to be binded to this host via a port. Okay, so bind functions does that job, binds the socket with the host name to the port. So the link is established using the bind function. Listen. Now listen functions tells the server how many clients you are going to entertain at a single point of time. So if I write listen in parenthesis 1, so I'm going to handle only one client at a time. Okay, accept is the function which waits, like server waits till clients accept the connection. It provides connection object and address of the client. So basically, accept function provides the connection object. As in the database management, we establish a connection between the database and the front end. So is here we are establishing a connection between server and the client. Receive and send. These are the two functions used on the client side as well as on the server side to send and receive the messages. The syntax of this will be taken care later on. Now, the one function which is there in client is connect. Server accepts the client connection, hence accept function is in server part. Now, client needs to connect to the server, hence connect function is on the client side. So these are the list of functions which are basic requirement, which are of basic requirement when we go for the networking in Python. The detail of each and every function is written over here. Okay, so let's go to the program part of the chat server communication, two-way communication. Okay, so if you can see, this is the basic chat server program. Okay, actually the first one is basic chat server program and the second one is basic chat client program. This is actually the chat client which is going to get connected to the server. Now, so as usual, import the socket. Then for the time being, we have taken our local machine as the local host where we can run our application. So local host we are using for running our application. Port number randomly I've taken as 9,000. You can go with 5,000. You can go with 4,000. And then this is nothing but socket object. As you can see, I have not passed anything to my socket function over here. So basically, I'm trying to say I want TCP/IP as my type of stream, and I want address family as IPv4. So that is by default. If you want to change, you can put the arguments accordingly. As I said, once you have got the socket object, next job is to bind the socket with the host and the port. Okay, host is nothing but the server, port is nothing but the point of connection from server to client where they meet. Okay, so host and post are both being bind to a particular port number, which is 9,000 on my local host machine. I am allowing my server only to connect to a single client, hence it is listen 1. You can have 2, 3, maximum 5. Okay. Next, accept function, as we know, helps to accept the connection from the client side. It is going to provide me two things. One is the connection object. Second is the address of my client, which is nothing but the IP address. Okay. Now, once this all things are done successfully, I'll get a print message, a client connected, if there is a client waiting on the other side or connecting on the other side. Okay, so once that is done, I am going to initiate the chat thing. So while true, data I'm getting received from the client, because client is going to send me the data first. So I'm receiving it over my connection object. So what's the importance of C over here? Once that connection object is being developed, on that connection, I'm going to receive, what is this 1024? 1024 is nothing but the how many bits of data I am allowing to come in one single cycle. So I'm allowing 1024 bits of data to be received in one single shot. Okay, if you're not getting any data, you can break the loop. Okay, so if this is not the case, what you're going to do, you're going to print what data you have got from the client. So from client, whatever is coming, decode it and print it over here. If you want to again send some data to the client, or because it's a two-way communication, so take the response from the server side and then send it over the connection object. So this is data one, because you have taken the response in data one, encode it and then send it. If you have used encode over here, on the client side, you're going to decode it. Over here also we have used encode, and hence we have used decode over here. So this is how it goes for. Once you have done, you are supposed to close the connection. So this was the server side. Same things more or less are on the client side. I'll just brief you out. Import socket, local host, the port number should be same for them to connect on a single line. Socket object you have built over here. Instead of bind, you have connect over here. So bind, server and port are bound over here. Here you are going to connect to the already existing host and port. So client gets connected to existing host and port. So we are taking the input from the client over here in str. Unless and until you put exit in str, okay, you're going to run this thing. So send, once you have got the things in str, you can encode it and send it. And then again, data receiving and sending part goes on, encoding and decoding comes into the loop. So that's how the things go on. If you can see at my side, at the right side of your screen, the screenshot is being, image is being put over here. If you can see, now how are you going to execute it? First, let me tell you that. Please try to open two command prompts, because they'll act as different, one as server, one as client. First, on the server, run the server program in one command prompt screen, and open the second command prompt screen where you can run your client program. You cannot do both of them in one single command prompt screen. So you need two screens to establish client and server connection. So a client is connected, as you saw. Once all these things are working fine, you'll get a message, client connected. If there is a client, of course, it will be printed only you have started the second command prompt screen and the program is running over there. From client, see if you have seen enter data. Hello, is there anyone? So the same thing has come on the server side over here. The server is entering the response. Yes, I am. A name here. So that is being sent to the client and so on. Once the client has written exit, okay, so the server has logged out of the session. Okay, so this is how a two-way communication between server and client can be done. Now you can try out along with some kind of front pages, developing some GUI, and then we can have a chat server application kind of thing. This was the basic thing of the basic chat server and chat client program. Thank you. If you have any queries, please go ahead. Sir?
I think let them come out with the questions. Otherwise, we'll go ahead with the next speaker so that we can capture if they have any doubts, let them put it in the chat box.
Okay, sir. Okay.
Thank you. Nice presentation, Professor. The next
Thank you.
speaker, is Dr. Comfort Olebara from Nigeria. Dr. Comfort is from the Department of Computer Science, IMO State University, Owerri, Nigeria. She is an expert in social media related issues in communication, data analysis, cybersecurity, cloud computing, AI, and its subsets. She has contributed to many local and international conferences, workshops, and journals. Dr. Olebara is a member of Association of Computing Machinery, ACM, Institute of Electrical Electronics Engineers, IEEE, and Computer Professionals of Nigeria. Currently, she is working on AI blending for smarter systems. She is a co-researcher in TED Fund project, which seeks to virtualize computer science laboratory practical teaching for National Open University, Nigeria. The floor is open to you, ma'am.
Thank you. I'm so glad to be here. I'm part of this family. I'll be presenting on optimization of business goals using Python programming language. Permit me to share my screen. I hope I'm audible.
Yes, ma'am.
Hello.
Yeah.
Okay. On my screen, can you see my screen?
It's still coming.
Okay. Please let me know when it's ready.
Yeah, I'll inform you. Yeah, it has come.
All right, thank you. Optimization of business goals has to do with implementing optimization processes such as the ones we have in operations research in such a way that the goal of an organization is actualized. The developer of Python, Guido van Rossum, developed this language in the year 1991. It is used for application, web applications in the server. It's also used to create workflows using software, combining it with software to create workflows. It's very effective in big data and complex mathematics, also rapid prototyping and software scripting. And we've seen some of these applications today in this workshop. So I'll be looking at its application in the area of complex mathematics. I'll be looking at its application in the area of complex mathematics. Operations research is a branch of computer science that deals with the application of scientific method to allocate limited resources. And the term was coined during the World War II when the British Army called on a group of scientists to integrate their new radar technology into the Royal Air Force tactics. So the success of operations research during the World War II made it quite popular in so many other areas of human endeavor, in organizations, in government management, and the goals management of different parastatals. Operations research has been proven to be quite effective. There are many techniques that are deployed in operations research. You have the linear programming, the non-linear programming, goal programming, and simulation modeling. So many of these techniques are tools used in operations research. We have five basic phases in operations research. The first is formulating the problem. In this phase, the organization that seeks to improve on their goals or to actualize their goals calls an operations researcher and explains the issues they're having, explains the goal of the organization and whatever it is they want to optimize or they want to achieve. Now, the operations research pulls these explanations or the contributing factors into variables. So these are called decision variables, and these variables are used in constructing a model. Also, there's no goal that does not have limitations, that does not have constraints. So these limitations are called the constraints in operations research. The constraints and as well as the objective function are used in constructing a model. That's the second phase. Construction of the model is bringing in the objective function and the limiting factors, the factors that impede on the success of these goals into an equation. So this equation constitutes what we have as the model. Now, the third phase is choosing the resolving method. This choice depends basically on sometimes the number of goals the the number of goals the organization intends to achieve. Sometimes it could just be a maximization of profits goal. It could be a minimization of cost. It could be minimization of time that it takes for the manufacturing to take place. So these are the things that determine the choice of method. Okay, and the relationship between the variables also determine the choice of method. So after choosing a particular method, the fourth phase is now brought up, which is resolving, applying that chosen method into resolving the problem. Now, after resolving this problem, of course, it has to be implemented into the real system. So this implementation is what we call optimization of the government, the organization's goal. So in optimizing the organization's goal, the set goal is either maximized or minimized. The objective function is either maximized or minimized. So these are the 5 phases that make up the operations research process. So coming down to optimization now, we need to define the variables. That's the first step. So we have 2 groups: first, formulation of the problem, and then resolution of the problem. In the formulation of the problem, we need to determine what are the contributing factors. These factors are called the decision variables. If it is a profit blending system or profit blending problem, we now know what are the products that go into the system, what are the factors that impede. Are we going to look at the number of employees? Are we going to look at the profit margin presently? Are we going to look at the raw materials that come into the system? What are we maximizing or minimizing? So these variables that contribute to these factors are brought in as objective functions, as decision variables. So in the next step, it will be the formulation of the objective function, where we intend to maximize or minimize depending on certain constraints. That's where we have to formulate the relationship between the limiting factors. Now, the next step will solve for optimization and then answer the objective question. So we have basic terminologies that must be used here. One is the linear function, we have the objective function, decision variables. All these have been described here, the feasible solution and the optimal solution also. So I'll be using some of these terminologies as I move on. The methods for optimization, the first one I'm looking at here is the linear programming method. Linear kind of means directly proportional, and this implies that the relationship or the contributing variables have a directly proportional relationship between them. So you know, like what we have when we have a straight line graph, the relationship between the variables are directly proportional. Increase in the number of inputs results in increase in the number of output. That means if variable x1 is increased, that means we still expect some kind of increase in its contribution to the overall system. So linear means directly proportional, and programming is concerned with optimal allocation of scarce resources. So this is the shape of what we are trying to resolve. Usually you maximize, this could be profit. X1 is a variable that is contributing to profit. So we have 400, X1 contributing 400 right now. X2 is another variable that is contributing also to profit. So we have profit right now is 400 X1 plus 500 X2. So we are intending right now, like this just the look of the model, intending to maximize this particular profits margin, subject to 4 constraints. So the constraints have inequality signs, which indicates the contributing variables as well as the available resources. Now, on the left-hand side, I have the contributing variables, which is the 6x1 and the 3x2. While on the left, I have the what is available in the system already. So we are saying that these contributions, x1 and x2, 6, should not exceed 300. That's, it should be less than or equal to 300. So one of the cases that we use this to test is employment, for instance. We are saying that, for instance, in a particular organization, that we don't want more than 300 people to work here, no matter the staff, the area they are working on. Let's say this one, some groups are working on establishments, some are working on manufacturing sector. So X1 and X2 should not, even if we have 10 different variables contributing to employment or departments in this place, please let all the contributions not exceed 300. So we say it should be less than or equal to what? 300. So if there is another constraint that we have to set a mark on, we still indicate. So this is just an example that will be further explained later. Then another example is nonlinear programming problem. We must agree with me that most real life problems do not have a linear relationship. So there's also accommodation for cases where the relationship between the variables is non-linear. So in this case now we use what we call sequential least square programming method to resolve nonlinear programming problems. And this is contained in the SciPy framework. SciPy is a Python framework, and it contains optimize.minimize. So the SLSQP is a subroutine that is contained inside the SciPy framework. Now, the next one we look at is the Go programming. The Go programming is actually a method or a technique that is used for resolving multi-criteria decisions. Let's say government organizations, they actually do not have single objective or let's say fewer objectives. Example is the United Nations Sustainable Development Goals, where you have a 17-point item or goals that the United Nations developed as a means of sustaining the economy of nations. So it is now, they actually believe the nations should work towards these goals, work towards actualizing these goals. You see some of the goals here. We have no poverty, zero hunger, good health and well-being, quality education, and gender equality, so on and so forth, up to 17-point goals. And these are made of what they call 17-point sustainable development goals. So what goal programming will do here is to prioritize the goals. Let's say the priorities in Nigeria might not be the priorities in another country. For instance, hunger level might be too high here. We might be setting it as our number one. Quality education, because of our education level, which is quite low now, we can set that as our priority, because I know that positive gain in the education will generally influence and sustain the economy of the nation also. So these are, in goal programming, whatever number of goals that needs to be actualized are set in priorities. And then the deviations from the target, there has to be an actual, what is on the ground right now is actual. What is the target? What we intend to achieve at the end of like these sustainable development goals. The target is by 2030, certain threshold should be achieved or accomplished. So what is the accomplishment level? That is the target. In goal programming, there are two factors that are important. Number one factor is setting the priorities. Then the second factor has to do with understanding the deviations. If our deviation is at by 2030, our level of poverty should not exceed 10% of the populace. And right now we have 50%. Of course, the deviation is obvious. So in goal programming, we penalize every deviation. That is how it is solved. We solve the problem by penalizing the deviations. So, and then the equation has to do with minimizing the deviations from the target. So in this first instance now, I have example, minimize Z subject to priority 1, deviation 1, plus 3 times priority 2, deviation 2. So this is how the model is formulated, depending on the deviations. So decision maker determines 3 key items here. What are the goals that should not be exceeded? So greater than, less than or equal to sign is used to denote that. Then which other goals should not be underachieved? So anyone that should not be underachieved, for instance, profit margin should never be underachieved. So we are using greater than or equal to sign to represent the relationship in the constraints. Then which are the goals that must be exact? So any deviation such as underachievement or overachievement will be penalized in this instance. So these are the signs that must be set by the decision maker in order to develop. Okay, so I just want to run quickly and give an example using linear programming problem. In this example, we have that the the manager of a particular company or a refinery must decide on the optimal mix of two possible blending processes, of which inputs and outputs per production run are given in the table below. You're asked to formulate the blending problem as a linear programming problem. Now, looking at the table, we have process A and process B. We have input section and output section. The inputs are crude oil, crude P and crude Q, and then the outputs are gasoline S and gasoline T. Of course, we have the profit. So firstly, we are intending to maximize what? Profit. What are we trying to maximize? Profit is 400 and 500. So we represent these with variables. 400 will have variable x1, while 500 will have variable x2. So we are going to maximize z equal to 400 x1 plus 500 x2. Now, subject to constraints, what are the constraints we'll be having? Looking at the crude P, we have we have 6 and we have 3, and then we have total availability there to be what? 300. That means 6x1 plus 3x2 is less than or equal to, because inputs, you try to reduce what you put into the system, but you try to maximize what you bring out of the system. So most times inputs are expected to be what? Low. So we are using, it should never exceed what we have as total availability. In that case, 6x1 plus 3x2 should be less than or equal to total availability of 300. Then 2x1 plus 6x2 should be less than or equal to 250. But on the end of the outputs, we should be expecting a higher yield than what we put in. So in this case now, we have 6x1 plus 4x2 greater than or equal to 120. On the gasoline T, we have 8x1 plus 5x2 greater than or equal to 100. So next slide. This is the formulation of the model. As already indicated, we have maximize Z equal to 400x1 plus 500x2 subject to these constraints. Okay. Okay. So to solve for optimal solution, I'm going to use this last example and see how we can solve this using Python programming language. We are going to be using Jupyter Notebook, and the POP framework will be used. Programming language is Python, of course. I kind of listed how you can install the POP. POP is a modeler written in Python. It contains solvers such as Gurobi, Coin, and so many other solvers inside of it. So you can choose any solver, and even if you don't choose a solver, it goes ahead and selects whatever default solver to solve the given optimization problem. Then you have to install Anaconda. Anaconda is an application that has so many applications inside of it. So inside my Anaconda, I'll be using the Jupyter Notebook. Thank you. Let me do a new share. Hello, sir. Can my screen be seen?
Yes, ma'am.
Okay. So this is my environment for programming. This is Jupyter Notebook. I would want to use a new notebook. Sorry, it's coming up, I believe. Okay, it's up now. Now, this new notebook permit me to simply collect my optimization problem from here. 1 minute, please. Okay. I'm simply going to copy the optimization problem described and paste it here. Sorry, can my Jupyter Notebook be seen, sir?
Yeah.
Hello.
Go ahead. Yeah.
Okay, sir. Now, in the Jupyter Notebook, there are two basic things we have. We have the code window and the markdown window. The markdown cell. We have the code cell and the markdown cell. We use the markdown cell for kind of commenting or indicating what we are working on. So right now, I just want to paste the problem I intend to solve. So I'm using a markdown window cell to do that. Okay, I'm showing here maximize z equals to 400 x1 subject to constraints. Okay, so now if I run this, I now need to start working on the code. So the first code I'm going to import is my pub. Okay, after importing pub, I need to define what do you call it again? The decision variables. Decision variables of the system. And my decision variable for maximization is only x1 and x2. So to define them, I'll have to say x1 is equal to pub dot LP for linear programming, and I'm declaring it as a variable in the system, pub dot LP variable. And then this variable is called process A. Remember, in my table, I have process A and process B. So I'm going to call this process A. Now, after calling this process A, I have to set the bounds. If you look up in the problem, you see that x1 is greater than or equal to 0, x2 is greater than or equal to 0. So I'm going to set low bound is equal to 0. That's for x1. So I'll repeat same, x2 is equal to pub dot LP variable. I'll call this process B. This is my process B. And I also declare that my low bound is equal to 0. Low bound is equal to 0. So with this, I can run Control Enter to run this. Is accepted. Then the next thing will be to set my objective function. Now I already declared the variable, so I have to define the objective function. So if it's required, I can just state what I intend to do next. Define objective function. Okay. Now do the work actual. The objective function is a maximization problem. So I'm going to use max z is LP problem. That's linear programming problem. I'm using this as instance, pub.lp problem. And then this is called profit. What am I doing? I'm doing profit maximization, of course. So I'll call this profit max. Then I'll state that it is where to find the application is inside pub.lp maximization. Now, maximize is the LP maximize. It knows that I intend to carry out maximization. If it is a minimization problem, I'll simply call pub.lp what minimize. Okay, so I'll run this. Now, after this, I'll start appending the factors, the variables to my work. So I still have my max underscore z to append of all to what we have as the variables. We have 400 times x1 plus 500 times x2. Okay, once you append the objective, or sorry, the variable that is set to the original objective function. So we have underscore, sorry, 6 times x1 plus 3 times x2 3 times x2. We have 6 or equal to, of course, in Python, we'll write them one after the other, less than or equal to 300. Then the next constraint comes in underscore z. We have to append, remember that all true. Append is equal to, we have 2 times x1 plus times x1 plus 6 times x2 is less than or equal to 250 this time. Then the third constraint comes in. We also maximize underscore z. Append is equal to, third constraint is 6 times x1 plus 4 times x2, 4 times x2, or equal to 120. Then the final constraint that we have here is maximize underscore z, maximize, then append these to 8 times x1 plus 5 times x2, which is also greater than or equal to 100. Okay, so let's do a quick check. The first constraint is maximize z plus 6 times x1 plus 3 times x2 less than or equal to 300. These are what we call it, Python operators. This is how we state it in mathematical form, representation. Then the second constraint, maximize z plus 2 times x1 plus 6 times x2 less than or equal to 250. I'm just trying to run a check and be sure there was no typo error. Then the third one is maximize z, appending it to 6 times x1 plus 4 times x2 greater than or equal to 120. Then the last one will have maximize z plus appending to 8 times x1 plus 5 times x2 greater than or equal to. So this is good to go. We'll run this and there's no error. Now to preview what we just ran, we print the contents by printing maximize underscore z, okay, to see. Okay, it shows us is a profit maximization, that's what we called it, and it is a maximization problem, and it gives us all the variables that we intend to use. So it states that these other 4 here are constraints. We have constraint 1, constraint 2, constraint 3, and the 4th one. And it states also that process A and process B are continuous variables. Okay, so having seen this, let's try to view the status of the system. We use pub.lp status to view the present status of our system. Pub.lp status, you use square bracket maximize dot status. Okay, this is supposed to tell you whether this system pub.lp status, pub.lp status, okay, our maximization, the objective function is maximize underscore z. Okay, so run this again, underscore z. Okay, right now we've not solved this, we just wanted to know the status. So the next case will be to solve the system. In order to solve it, you use maximize underscore z dot solve, and then you make it a method. Fine, it has been optimized. Now, showing you that it is 1 shows that it's optimizable and it has been optimized. So what we now need to know is the contribution of each of the variables, because the need for optimization is to have an idea, an insight through which decisions can be made. So once our optimization or our solution shows 1, that means the system has been optimized. So the next thing will be to know the contribution, what level of X1 should I put in this system, so that as I'll be making mistakes and losing money, in this case now I'll make an informed decision. So we are going to view the contribution of each of these variables to the system. In order to do that, we are going to say status. We'll look at the status here and the optimized value. Put a
Doctor,
comma
sorry to interrupt you.
and say optimal.
Dr. Comfort,
Sorry?
sorry to interrupt you. Yeah,
Yes, sir.
the time is up.
Okay.
Please. Okay.
Okay, do
Please
I
continue.
have like 2-3 minutes? Okay, I'll
Yeah,
tidy up now.
okay.
Okay, so, all right. Okay, so with this, I'll use the first for V in max underscore Z dot variables, print, we're going to see the contributions, print V dot name, put a comma and say equal to V dot variable value. Okay, so let's run this. Okay, it's telling us that process A should be 35.0, while process B should be 30.0. So this is the resolving of the problem. Finally, we have the implementation, which you just have to say print out for me, print the optimal solution is, okay, you have pub value, bring that into your maximization problem, maximize dot objective. So this is the last dot objective. Okay, so let's run this. Fine, it's telling us the optimal solution is 29,000. So this is the point at which our profits will be maximized. And the contributing factors or contributing variables will be the process A and process B, where process A will contribute 35 units and process B will contribute 30 units. So this is example of how this is done. And with this, this for linear programming. And once it is nonlinear programming also, we have, like I said before, the sequential least square method, and that could also carry out the same processes and give you the optimal world solution. Thank you for having me today. Thank you.
Thank you, Dr. Comfort. Participants, is there any questions for Dr. Comfort and Dr. Mannat? Okay, if you can type it in the chat box, we can share it to the experts also. Now, as time is running out, we'll go to the next person, Anuj Shah. Anuj Shah is a data scientist from Deloitte. He handles US and Indian clients. His core competencies are supervised and unsupervised learning, classical to advanced ML algorithms, NLP, time series, model comparison, model interpretability, and he's handling bigger projects and client base. His experiences onto predictive analytics, machine learning, web development, and consulting. He is certified in OCJ Java from Oracle. He has done machine learning courses, and he is an expert in data engineering and big data. His CV is quite big, so let me cut short and give time to Anuj. Anuj, the floor is open to you.
Doctor. Thank you, Dr. Krishnan. So I would like to thank all the speakers for setting up the context. So I'm sharing my screen. So starting off with the machine learning. So my topic is a little bit vast, and I'll try to like complete a few point and as per the OpenCV, I'll just make a scratch as well here. So um, what do you mean by machine learning is it's a sub part of artificial intelligence, and we have a different section called deep learning as well. So what is machine learning? Like if you understand, it's like machine solving the problem on its own based on the past learnings which are already present in the system, or try to evaluate the situation and to take action on the situation and give an output. So this is classical meme, what we see it on internet. What is machine learning? Like a machine is teaching another machine, which is actually the case, but for the purpose, I'll share the definition of Google. What it describes as like it allows businesses to enable to teach the system how to solve problem at hand with machine learning algorithms and to get better over time. Uh, the last part of it, I'll go with in the slide. And these are the classical roots of machine learning and artificial intelligence. So there are different type of problems, not all fall under one thing. So as we have mentioned, deep learning, unsupervised and supervised. So if I try to explain what is supervised and what is unsupervised is like you're given like in your Gmail account. How does Gmail know that this one, the incoming email is spam or not? So that is general knowledge from which it will try to predict whether it is a spam or not spam. So that is unsupervised, and supervised is based on certain input parameters. Input could be like imagine you are driving a car, and when you are driving a car, it acts as a container which will take multiple inputs like clutch, accelerator, a gear, and the steering wheel. So the output is you are driving forward or you're moving from the location A to B. So that is how you know that you are expecting something out of given a different inputs. So that could be thought of as a supervised learning. I'll give you an example in a bit, but the other classification problems are there, translation problems are there, context extraction is there, question answering is there, text generation. This all the models I am sure that you might have come across, like question and answer could be a chatbot answering FAQ, Q&A kind of questions. Context extraction is like we can extract some information out of some large text. Classification is like to identify whether image is of person or animal, or which animal. That could be a classification. Machine translation could be you can see Google translation in the process. So NLP is the one of the root branches. Now, not spending much time here, I'll just put this little smaller. Okay. So we have a problem statement. Let's say we want to predict whether it will rain tomorrow or not. With this question, it comes with a lot of another questions based on that is why it is useful, like what will it help, what will it solve the purpose. So here we have a weather predicting model, and it does a simple thing, whether it will rain tomorrow or not. So it will help as you might have noticed in one of the speaker, I think Mahesh, it was showing in the Windows machine as well that it will rain or not. So those kind of model is based on location. So here also we have this machine learning model which will have some goal. So the goal is to predict there will be rain, light rain, or heavy rain. Now, given the region, different data, so I have downloaded this data from BitGrid website. So there is a competition which is ongoing, and we have to predict whether it will rain tomorrow or not. So coming back to the slides, we have so before going on to that, I'll just highlight what is uh, like a little bit on deep learning models, which you might be interested to explore. So I have a DALI model, which takes a famous poem, nursery rhyme, Jack and Jill. So it depicts this image. This is the original image which I have supplied, and it generates different variations of it. Now, even if I can put some abstract sentences as well, and it can predict some of the things. So here I have put in the whole rhyme, and it has predicted somewhat near to the image which I already supplied. I also tried Twinkle Twinkle Little Star rhyme, which also kind of the words imagine this scenario. These are not the real images. This is totally machine generated images. I can even like put this panda in a Iron Man suit in space. Now, machine doesn't know Iron Man, so it tries to take the word suit and it puts a panda in a space. There are other examples like a panda stitching a dress on mountain. So these are some abstract ideas. It really like generates this image. It understands the context. Now, um, to take a simpler example, like whether it will rain or not, I'll go on to some other example, whether to play tennis or not. So based on several inputs, because rain, I have the data in the demo as well, but predicting that would require a little more understanding. So I'll just go through some basic data, and then I'll move back to that example. So if we have inputs as outlook, sunny, overcast, rain, temperature, hot, mild, cold, and humidity as different variations. So if you see the first two rows are, and our output is to play tennis or not. So if as a human, we try to understand, we take this one variable itself at very first. If it is sunny, play tennis, no. If it is sunny, play tennis, no. But when it comes to temperature, I take a combination of temperature and outlook, which is sunny, hot, play tennis, no. If I take sunny, mild, still it is a no. So I may think that temperature plays an important role or not. So I can go to some other example where sunny, cold is there, then only plays yes. So for now, I understand that if it is sunny and if it is cold, then only I have to play tennis, otherwise not. But then as we move on, the combination and permutation of variables increase. And as a human, we can't attain all the like parameters. Now, the model which I showed earlier, Delhi, it takes around 1.2 million, I think, rather than quoting the wrong number, but in millions and trillions parameter, it takes as an input and it gives output. So, uh, so here in this model, we are trying to predict whether to play tennis or not based on several inputs. Now, likewise, if I move back to my original statement, so we have this data available for different regions, and we have a solution format and solution train as well. So that is the expected output, and we have the test region as well, test data for the region, different region as well. So one thing to be clear over here, that it wants a model per region only. So it should take several inputs, and I'll show you the data. So if you can see, here are the like different columns. I think it's 10 columns, and we can see notice that date isn't a date. Actually, it is anonymized feature here for with some random value, so we don't know. So these are the challenges um, usually come when it comes here like data anonymization, data governance, and these are the different topics which are separate domain within the machine learning field. So we can see that this is the output format which they want. A random string will be given, and this random string will be attached to some variables, and it should predict no rain, light rain, or heavy rain. So we call the output as the target variable or label, and the input as input features. So we can utilize that to join the training column and do some cleaning. So I'll straightforward go to the demo part. So I am using Google Colab, which is similar to the Jupyter Notebook as presented from the previous speaker, and we can drop in our data over here. So so it is connecting to runtime. Let's not execute it, but I'll try to help you understand what I'm doing is. So here are the import statements. These are the libraries. And if you are not new to Python, this is the library sklearn, which is a library which has all the major machine learning algorithms. Now, which algorithm to use totally depends on trial and error and domain knowledge, as one might like proceed in this field, might come across different algorithms, advantages, disadvantages. So we are actually having two utility functions over here, and we can see that we have this data unzip, and we have different CSV as we have seen in the PPT. Now, this is the same data as we saw earlier, and we are having um, the different data types. D type here means the data type. So object is a generic data type. So we don't have to be confused why what does object mean. But the float means it will have some decimal values after the number, and we can see over here these are the column available. And after combining all the region data A, B, C, D, E, we can put this like this. So a data frame is nothing but you can assume Excel sheet attached and combined all together. So what we are doing over here is we are combining and we are putting and cleaning the data. So as you can see here, A, B, C, D, E is separate, and here we have a new column called region. So now we have 11 input, and we have to just predict whether it will one of the states. So this type of problem is called classification problem, wherein we are trying to predict so one of the category as in no rain, light rain, or heavy rain. So we are seeing that the data consists of no rain more. So if we see that it may try to, if we don't balance it out, it may try to predict the more classes on no rain only, because it has seen no rain data more. So these are the graph where we are trying to generate different region data. So I'll just scroll down. So region A, B, C, D, E, different colors are present, and we can see that in region A and B, maximum wind speed is more. C, it is less, and wind speed over here is meter per seconds. So we usually need to convert it into knots. So below, similarly, this is done on the test data as well. But and we can see out of all the data, minimum atmospheric pressure contains a lot of missing values. Missing values will hamper the model because it doesn't know what to interpret when predicting the output. So we can see that the distribution of that particular column is normal. Now, normal as in from the data science term, normal means this bell-shaped curve. So it is evenly distributed. In the center, it is there having high number of values. And uh, the parts which we are doing here is called feature engineering. Like machine doesn't understand like string or text. It does understand only numerical values. So what we are doing is we are labeling this output to 0, 1 and 2. So we can even do it for other columns as well. But as I told earlier, that the wind speed is in meter per second. So we need to do scaling into knots. So Buford is a scale which is domain knowledge. So it may happen in this field where people might not have certain domain knowledge, and there we need some subject matter expert. Skipping this complicated part because it does nothing, just cleaning the data and training the model. So I'll come to the model prediction part, where we have nothing but we are doing train test split, and we are taking 30% into the testing part. So whatever data is there, we will take 30% into test to understand whether our model is working fine or not. So these are the metrics where we are actually having 62% accuracy, which means 60% of time the model will predict the right output, but the rest 40% of time it may have the error. So let's say we have 1,000 samples. So 1,000 times we want to predict from the model that it will rain or not. So 62% of time, like 620 instances out of 1,000 would be correct, but the rest 40 38% would be incorrect classified. So this in machine learning is always there. If it is 100% correct, then it is too bad, because it there are concepts where it will always fail. So that we need to think of. Now, precision, recall, F1 score, and support are the different terminologies. Precision is what I told you, that how much accurate is what percentage of predictions are correct. Recall is what are the positive cases, like it predicted yes it will rain and it rains. So, and there is F1 score, which is a combination of precision and recall, and we divide it. So there are different formulas, and support is number of entries, like total whatever number of entries are there in the data. If 29% is the precision, then how many records are under that 29%? Because it may be relative, that I have 1,000 records and then it is 29, then it might be little bit less accurate. uh, so later on, what we do is we can save the model in one file known as pickle. So we can save this model, and we can, as Sangeetha ma'am was showing the Django framework, we can put this pickle file into Django, and we can make a weather predicting app from there. So, and in the last cell, we have the solution file, but since it will take a little time, we can skip this, and we can move back to our the slide, where we can see that we can combine the data and we can predict the output where it will rain or not, light rain. So we can see that the first two instances are it will not rain. On the fourth entry, it is showing that it will rain, and on the fifth entry, it says that it will not rain. So these are some of the ways we can do it to predict rain. But there are many trial and error we can do. We can use different algorithms to increase the accuracy of model, and we can also like have different models working together. So if model 1 predicts it will not rain, if model 2 predicts not rain, and there are 10 different models, and if 9 are saying it will not rain and 10th one is saying it will rain, then it is 90%. It acts as a voting classifier. So we can combine different models and techniques to be sure that whether it will rain or not. And even after there is a gap of error, that it will always be there. So that was it from my side. If you have any doubts, you can connect me via email as well as on the LinkedIn. So hope you guys enjoyed. If someone wants to explore this DALI, you can like Google search, and this is a link, labs.openai, and you can experiment on this. Kaggle is one of the platform where you can get a lot of data, and you can predict, you can write your code and contribute and understand from different contributors. So that was it from my side. Thank you.
Thank you, Anuj. It was a nice presentation.
Thank you.
Participants, if you have questions, please email to us because it's more time gone today. Okay. Thank you all for your participation. Have a nice day. We expect you for further more programs. Thank you all.
Thank you all.